Hi, in this series, let us talk about the mathematical interpretation of the word of in the phrase A over B of C over D. So, we often encounter this, a fraction of a fraction. So, we're going to discuss what that really means. So, let's start out with some simple examples. When we write 2 of 10, think of a situation where you have a $10 note in one hand and another $10 note in the other hand. So you have two copies of $10 notes, and that's clearly 20. So 2 of 10 is a shorthand version of two copies of 10, and with that knowledge it's easy to see that 2 of 10 equals the number 20. Similarly, 10 of half is, if I say, is the shorthand version of 10 copies of half. It's easy for you to add 1 half plus 1 half plus 1 half, 10 of them, and arrive at 10 of half equals 5. So now let's look at this example, 1/3 of 3 or 2/3 of 3. These two are different from this. Here we had a whole number of copies of the other one, so we could count off 2 of 10, 10 plus another 10. So here it's a different situation, 1/3 of 3. What does that mean? There is a definition for this. When we write this, there is a precise meaning for it. And let's discuss that on the other board. So here's the precise definition for 1/3 of 3. 1/3 of 3 is the length of one part when the segment from 0 to 3 is partitioned into 3 equal parts. So what we're saying is 1/3 of 3, when we write it, this is what we mean. We look at the segment 0 to 3, so this 3 matches up with the segment 0 to 3. And this denominator 3 is telling us, let's partition this segment into 3 equal parts. 3 equal parts. And we're saying 1/3 of 3 is the length of one such part. So from the picture, it's clear that if this segment is of length 3, and if we subdivide it, partition it into 3 equal parts, then this number is 1 and this number is 2. And so the length of one part is really 1. And so we conclude 1/3 of 3 is 1 by this definition. And now let's look at the expression 2/3 of 3. Similarly, 2/3 of 3 is defined as the length of two such parts. So the numerator is telling you how many parts you're taking. Two such parts, you concatenate. So now you're looking at this, and that is what is 2/3 of 3. And clearly you can see from the picture 2/3 of 3 equals 2. Let's look at more examples. 1/4 of 12 is the length of one part when the segment from 0 to 12 is partitioned into 4 equal parts. So this 12 tells us to consider a segment of length 12, and the 4 in the denominator is telling us to partition this segment into 4 equal parts. And by definition, the length of one such part is 1/4 of 12. So it's easy to see that if you take a segment of length 12 and partition it into 4 equal parts, then each part is of length 3, 12 divided by 4. So these numbers are 3, 6, 9, 12. So what we figured out from the picture and using the definition is that 1/4 of 12 is 3, because 1/4 of 12 is the length of one part when this segment from 0 to 12 is partitioned into 4 equal parts. So 1/4 of 12 is 3. 3/4 of 12, the numerator 3 is the only thing that's different from this example. It's telling us we should look at the length of 3 such parts. So take this piece and concatenate 2 more pieces to it. So if you got the length of 3 such parts. So as you can see from the picture, 3/4 of 12 is 9. 7/4 of 12, similar idea. This 12 is telling us look at the segment of length 12. This 4 is telling us cut up the segment into 4 equal parts. And 7 in the numerator is telling us look at the length of 7 such parts. We just figured out one such part is 3. 7 such parts. We don't have it in the picture, but we can visualize it. Each part is of length 3. If you concatenate 7 such parts, the length of that part would be 7 times 3, which is 21. So we figure out all of these purely from the definition and with the help of the number line. Let's look at a few more examples. So let's look at 1/5 of 100 and 8/5 of 100. Just as before, this 100 is telling us, let's look at a segment of length 100. This 5 is telling us, partition this segment into 5 equal parts. 1, 2, 3, 4, 5. And by definition, the length of one such part is 1/5 of 100. It's easy to see if you take a segment of length 100 and partition it into 5 equal parts. Each part will be of length 20. So that's how we get 20, 40, 60, 80. So what we figured out from the picture is 1/5 of 100 is 20. 8/5 of 100, the numerator is 8, is telling us consider concatenating 8 such pieces, and 8/5 of 100 would be the length of that concatenated long piece. Each piece is of length 20. So if you concatenate 8 such pieces, the length would be 8 times 20 or 160. Let's continue this discussion in the next video. Thank you.